Afternoon. I was going to say good morning, but it's good afternoon. My name is Andrea Carice. I am the Acting Associate Vice Principal of Research and Innovation with a focus on strategic initiatives and partnerships here at the University of Toronto, Scarborough. I'm also an Associate Professor in the Department of Health and Society at UTSC. And with respect to the Earth District, I also have the pleasure of chairing the Earth District's Research Committee. Before we get started, I'd like to acknowledge that Fleming College respectfully acknowledges that they are situated on Mississauga lands and traditional territory covered by the Williams Treaties, and that we are grateful for the opportunity to work and teach here. We thank all generations of people who have taken care of this land for thousands of years. We recognize and deeply appreciate their historical connection to this place and recognize the contribution of Métis, Inuit, and other Indigenous peoples, both in shaping and strengthening this community and country as a whole. This recognition is connected to our collective commitment to make the promise and the challenge of truth and reconciliation real within the Fleming community. One step that Fleming has taken in this respect has been the signing of the Colleges and Institute Canada's, or CCAN's, Indigenous Education Protocol, IEP, which has symbolized Fleming's commitment to fortifying relationships with Indigenous communities while embedding intellectual and cultural traditions as understood by Indigenous peoples into curriculum and activities. So we recognize, I myself am joining from Scarborough. You others on the call may be joining us from different geographical locations. Using the link that Jess will be providing in the chat, we'll encourage you to learn what traditional lands you are on. So welcome, everybody. Thank you for joining us for today's session in the Earth District Speaker Series. As you may know, Earth District is a 5-institution consortium of universities and colleges committed to developing the sustainable technology sector in the Eastern GTA and beyond. In the heart of the Eastern GTA, the Earth District, the Environmental and Related Technologies Hub, stands boldly as a catalyst for sustainable innovation and collaborative change. Indeed we do, and here we are. This speaker series has been taking place throughout 2025 virtually and led by our Earth District Consortium members that includes Centennial College, Fleming College, Ontario Tech University, Trent University, and my own institution, the University of Toronto Scarborough. The Earth District Speaker Series is a dynamic forum designed to showcase innovative ideas, foster collaboration, and highlight the expertise in our community. We hope that you enjoy today's session and that you'll join future ones. Jess will be providing you with links to our future programming activities. We're going to be continuing into 2026 with sessions currently in the process of being booked, but our next one will be on January 29th. More details to come. So just a few more housekeeping items before we begin. Teams does have a closed captioning feature. If you want to utilize it, please click on the More tab at the top of your app, slide down to Language and Speech, and click Show Live Captions, pardon me. We will be, and currently are, recording the session to share later on the Earth District website for those of you that wish to view the event or integrate it into your teaching and classes, as I highly recommend you do. Please also use the chat function for general comments and networking, and the Q&A box specifically if you've got questions for the speakers. We're going to be monitoring the chat. We're going to flag any discussion questions, and we'll ask you to, if you are going to offer questions, to hold them to the end. But of course, you're welcome to use the chat if you'd like to get something off your mind and onto paper, as it were. You know what I mean. So. I will now introduce, as my final act, I will now introduce today's speakers, Ferdun Diba and Mehdi Sanjari. Ferdun Diba, PhD, PEng, PMP, FEC, is the director and principal researcher at Fleming College's Center for Applied Machine Intelligence and Integrated Technologies. Dr. Diba holds a PhD in mechatronics engineering from Ontario Tech University and is a registered professional engineer and project management professional with a successful record of academic and applied research. His main research areas include mechatronics, product development, hardware design, and advanced manufacturing. Over the past 5 years, Dr. Diba has secured more than $7 million in research funding as an applicant or co-applicant. He's also the author or co-author of more than 25 papers and is adjunct faculty at Ontario Tech University Department of Engineering and Applied Science. He's also a brand new member of Earth District's Research Committee. Welcome. Our co-presenter for today is Mehdi Sanjari, PhD, PEng, who is the CEO and co-founder of AI Innovate, a company delivering AI, ML, IoT, and Industry 4.0 solutions for automation and digitalization. With over 15 years of experience in engineering, research, and entrepreneurship, he has co-founded and supported ventures in software, manufacturing, advanced material, and agriculture. He earned his PhD in computational materials science from McGill University and published in several leading journals, receiving multiple awards and fellowships. Passionate about innovation and impact, Mehdi aims to leverage expertise and networks to create value for students, partners, and society, and indeed, I hope, the Earth District more broadly. I will hand things over to Faridun and Mehdi for their presentation. And thank you so much for taking the time to present with us, and to everyone tuning in for taking the time to learn from our speakers today. Thanks.
Thank you very much for the introduction and opening the session. So I am going to share my screen shortly, but before that, I also want to thank all the attendees and all the people here that spend their afternoon with us, and I hope that this presentation would add some knowledge and also learning experience for you about the journey that we had together with AI Innovate to develop new products, solutions to help the Canadian industry to innovate. So I'm going to start by sharing my screen. Okay, so can I have a feedback if you can see my screen? And
Yep, all good.
Awesome, good, thank you. Okay, so today talk about AI innovation, manufacturing, and telling us how a customized AI hardware can be developed for manufacturers through academic and industrial collaborations between a research center at a college and a manufacturer, and also a service provider, a technology provider in AI field. So I'm just going to start by maybe better to introduce first my research center and type of the work we do, to give you a little bit of the background and how the journey that we will talk about happened by having the ability and capabilities at CAMIT. So CAMIT, or Center for Applied Machine Intelligence and Integration Technology, is an applied research center in Fleming College, Peterborough campus. And our focus here is mainly on developing hardwares for electronics and embedded systems, which are very commonly used in a variety of industries, but we are mainly focusing in edge AI and machine visions and application of AI in industry. So we develop and are developing lots of different customized solutions for our partners to be able to use the power of AI according to the needs and limitations at their facility. On the side, we do research and advanced manufacturing, helping our partners to develop processes and technologies in that field, and do product development in both embedded systems, mechatronics, and advanced manufacturing as a separate focus stream. So we are providing a variety of research services to our partners, from engineering consultation, feasibility analysis, all the way to full product development. So the center is able to develop products from a napkin, back of a napkin idea, all the way to a market-ready product. We have a couple of success stories of that full journey with our partners. Also, we do prototyping at different stage, whether the partner needs it or whether part of our product development journey. And also testing and validation of electronics and mechanical systems is another service that we provide to our partners. And the lab and the spaces that we have are well equipped for these kind of services and helping the in Canadian industries to innovate. So we have a strong research team, more than 15 researchers in both mechanical and electronics side areas, plus computer programmers and computer software engineers that helping to make controls and the intelligence systems. So it's about 3,100 square feet of dedicated research space with 2 research labs, 1 research shop, 1 prototyping room, and office spaces, and have more than $4 million of equipments in all related areas of electronics, advanced manufacturing, and computer engineering to enable the whole ecosystem that we're providing to our partners. So now I just want to first lay out the ground for why AI in manufacturing is important and getting momentum in the recent years, and what advancing in world of AI and machine learning enabled this speedy and fast adoption that is kind of not enough in Canadian industry adopted, but we are trying to help the companies to be able to catch up to speed and get advantage of these new advances. So generally, AI adoption is an important part in the global economy. So it's assumed that the AI can contribute up to $30 billion, $15 billion in the next 5 years, trillion dollars in the next 5 years to the global GDP. And in that, it comes from different advantages that AI is able to offer, whether it is improving the quality, improving the labor productivity, personalizations, and also time saved in operations and production processes. However, there's only about 9% of the manufacturing executives that reported to implemented the AI by now. So there is a huge potential to be considered, to be take advantages of adding these advances in computer engineering and AI world into the manufacturing and into the more of a traditional industries. So just to have a little bit of a picture of how the AI is going to help different industries by 2030. So the graph below shows you the each industry for comparison, which might be in the sector of the manufacturing and constructions. I would just want to point out the difference between China and North America in terms of the impacts of the GDP on the growth of those sectors. AI in the GDP growth of those sectors. And you can see that we in North America, with all those advances, still kind of lagging behind of one of our main competitors in the global market. So it is estimated that China will have up to 25% of GDP impacted in that sector of the industry by adoption of AI, while in North America, that's around 10%. And I assume that's going to be even lower number in Canadian industry and Canadian manufacturing, as historically there was always a little of lag comparing to adoptions in United States. So that shows us how important is the adoption to be considered, and also we need to accelerate this adoption of AI in manufacturing and improving the quality of the products and also efficiency of the processes that we adopt in the manufacturing in Canadian sector and industry. However, there are many benefits that the AI bring to the manufacturing industry. Just to point out, the two one is I mentioned. One is so AI will enable the manufacturers to automate their process, augment their work, and also having a better productivity among their workers and manufacturing workforce. So that is eventually turns out to be saving on the cost of the manufacturing overall, whether that would be higher productions, over the span of the time, or less waste resulting through the manufacturing processes by having better and more focused quality control processes. Another area that the AI can help the manufacturing industry is increasing the customer demand. So when the customers see the benefits by receiving better quality products, receiving much more effective products, that's being possible and enabled by adoption of AI in the process of manufacturing. So you will have a better growth in the market demands, and as a result, more business and more revenue can come towards the manufacturers. So speaking of these, that means that's showing us the importance of the AI adoption in manufacturing. And in the manufacturing industry, there are many areas that AI can specifically help the process. So whether it's in engineering and design of a new product, or into the production and optimization of the processes, and also optimization of assets utilizations, in quality management of the products or processes, AI can be a powerful tool. In worker safety and productivity, improvement in supply chain and reliable, and also in smart products and machines. For the sake of today discussions, we want to focus on how AI can help the quality management and help the manufacturers to improve their quality management processes by adopting AI technologies. So the adoption of AI technology in the recent years, as I mentioned, is getting momentum and being considered more widely. And also, it's now much more easier to be adopting these technologies and these benefits in the production processes. There are a couple of reasons around it, but from the technological point of view, the recent advancements in the AI and the world of machine learning enabled easier and much more cost-effective adoption of AI technologies. Just to name a few of these recent advancements, one is the improvement of the deep learning models, and which are technically the backbone of the machine learning and the AI technology in general. So by developing much more better, effective, and deep learning models like the convolutional neural networks or transformers, now training machine learning algorithms are much more effective and easier for the technology adopters and for different kind of applications. In addition to the yes.
Sorry to interrupt. I think, would you be able to turn off your camera just because your audio is lagging just a little bit, and turning the camera off might help?
Definitely.
Please, thank you.
No worries. So in addition to the, I hope it's better now. If you need it, let me know. But I keep continuing. So in addition to the development in the area of the learning models, also the hardwares are evolved rapidly over the recent years, specifically edge AI processing units. So means now we have much more powerful processes to get the informations collected from the physical world through different kind of sensor cameras and process them on the edge of the internet, which means where the physical world is connected to the digital world. So we can process those information on board at the location and make decisions or actions much faster with these edge AI processing powers that are available. The other advantages are anomaly detection models are now much more effective. They have different type of these anomaly detection models developed. There are many of available libraries and data sets that help technology adopters to start the process. However, that has to be said, in some of the industries, this is going to be a challenge still to collect the required information, the type of data required for the training the models and anomaly detections or deep learning models is also still a challenge, and in many cases it would be a very costly part of the research and development of the AI for manufacturing. Attention mapping tools and that helps to visualize AI decisions is another important part of the recent advancements. There are now AI tools development platforms that do not require any coding and make people with the minimum knowledge on coding to be able to develop AI solutions for much of a simpler applications. And also synthetic data and self-supervised learning models and technologies are able to train these deep learning models much efficient and cost effective. So as I said, today we want to focus on how quality control in manufacturing can be enhanced by adoption of AI. So there are some key points that this adoption of AI can help the manufacturers. One and most important one is to minimize or eliminate the manual inspection of the products on the production line. So this is the story that we will talk about today is a very good example of how development of an quality control machine vision based system can eliminate the need for having a tedious job of inspecting products on a production line through visual inspection, which also resulting in better quality of the product and less rejections and having a better confidentiality in quality of the product to be delivered to the market. Also, addition of this AI-based quality control systems enable the traceability in the production and also make more consistent product as a result. The adoption in most cases required not that much of a huge investment from the manufacturers, and some manufacturers do have a limited resources to adopt these technologies, but as a result, by having as I said, the advantages in the recent years, making it much more cost effective for them to develop. And also, in many cases, we see the manufacturers do not know yet about what can be done or what are the power of the AI that can help them to improve their quality control processes. Addition of AI-based quality control systems bring many opportunities to manufacturers. First of all, they would be able to have a real-time data from the production line about the quality of their products at different stages of the production. Also can automate the defect detections and making sure that these defect detections are consistent and traceable. These technology can provide predictive insight to the process, resulting in less waste and also time of the operation. Scalable. This will be for small manufacturers all the way to very large manufacturers and companies. In our example today, we see that the system we will discuss is developed for small manufacturers, while the same system is being now deployed on a larger manufacturers with a different type of product. So now, why, by all these discussions, why a manufacturer has to consider AI-powered quality control? So just to summarize my discussions, it will improve the quality and reliability. It will reduce the cost of the poor quality, which means less waste and better market confidence. They can boost productivity and meet compliance and standards. Also, these AI-powered quality controls can gain competitive advantage and support predictive maintenance, so which can resulting in less time of the machineries and better use of resources and investment on the production line. So to develop an AI-enabled quality control, there are a couple of processes and as we call it, a journey that has to be gone every time based on the needs of the and the managers. So there are two main streams. Every of these development works needs to be having development of a product, and also the second one, development of the process. So we need to develop a development product consists of first gathering the data. So as I said, data in many cases we are able to find openly available data sets, but in some cases, we do need to generate that data ourselves. So collecting can be a cost, time-consuming. So that's PSR point on each of these AI to control developments. So with the data, we will be able to train the machine learning model and bring that to a stage that this models be able to predict and implement it in the operation of the process. And then we can formulate those and run pilot trial for final delivery and final installation on the manufacturing line. The process development mainly involve of developing the hardwares and special equipments in the process. So that consists of selection of the proper camera, lighting setup, equipments that needed for installation of those on the line, processes for acquiring the images and also the processing those data, defining the machine learning classifiers, and also finally the front end that provides the real-time data dashboards and alerts to the final users. And every time that we develop the AI-enabled quality control process for manufacturers, we've gone through both of these sub processes. And as the technology is being developed, you will have the advantage of reading the models or the steps that done for the previous technology or previous manufacturer for the new customers and new manufacturers to work on. So this is going to end up to be more of some tweaks here or there, or improvements on the process on the hardware. In case that there's no data, we're just mainly focusing on gathering, training, and learning models. So now here I want to introduce you to one of our partners, AI Innate, a company that we've been working in the past 3 to 4 years. And I'm mostly need to talk about it shortly, and then we discuss how this collaboration is shaped.
Thank you, Feridun. Can you hear me well, everyone?
Yes.
Okay, good. So thank you, Feridun. So as we are at AI Innovate, try to employ like computer vision and machine learning for the different sectors and try to drive the efficiency and raise quality. That's our general mission. We co-founded. I co-founded with 2 other of my friends and partners, Payman and Omid, back in 2020. The company, it was started firstly based on the project that we are trying to implement machine vision and machine learning mainly in the manufacturing industry, and later on we are developed a few products, like 4 products we are commercializing right now, and then it has been implemented in the different industries such as textile, metal, paper industry, polymer industry, and packaging. So far, we will, along with Feridun, we will tell the story of the first product, AI2i, today, and how this collaboration ended up for commercialization that products. And so can you go to the next slide?
You see my screen, team?
Yes, but it's still on the first slide.
Oh, is it?
I think, yeah, you have a bit of delay as far as yeah. So yeah, generally that's how we started, and if I'm just trying to, in the next slide, trying to explain how our process and AI to AI generally works. And we have usually a data acquisition part, which is might be different cameras or different sensors. It could like line scan cameras, area scan cameras, or recently we are also dealing with hyperspectral cameras or even like thermal cameras. And after we acquire those data, we are trying to train a model and then have a best structure for them and optimize that our machine learning model. And in the next step, we are trying to classify based on that and the train model the input that we are getting mainly from those sensors or cameras. And with the gathering all those information, we are trying to get back to our clients with the optimized process and try to increase the efficiency and also the quality of their products. Yeah, this is the common products unit that we are offering to our clients. As I mentioned, there is a data acquisition unit. It could be the data could be collected through the different type of cameras or different type of sensors. And then we have the defect detection unit, which is we are labeling the data after we're collecting it through the first phase, and design an ML structure and train that for the detecting the defects. And based on the train model, we can classify the what type of defects that we are dealing with and define some criteria for the sortings, or also try to do some root cause analysis for why this defects or imperfection is happening during the manufacturing process. And based on that, the last phase that we are doing for our client is that process optimization. So try to finding a correlation between the process parameter, environmental parameter, and also the defects types forming during the manufacturing process, and do the optimization accordingly. So that's the common process that we are doing so far for our client. And back to you, Freydin.
Thank you. So I hope that my voice is better now. I switched my internet service here. So now I just want to talk about how we build a turnkey solution through this collaborative journey with AI Innovate and another partner that I will shortly introduce them. So we started working with AI Innovate back in 2022, where they approached us for helping them to manufacture a special conveyor system for training the AI algorithm that they had under development at that point. And we were able to work with them through support by NSERC and helping the AI Innovate team to train their machine learning models for one of their customers at that point. Maybe you want to chime in here and talk about that more. Yeah.
Sure. Yeah. So back in 2022, as Freydin mentioned, we were involving a project in we are developing a defect detection unit for aluminum machinery manufacturing casting in Kingston. So over there, they are delivering a new IP for making a thin aluminum sheet out of melting, like a twin roll cast process. So they have a problem with forming the defects, and they want to do the root cause analysis, why this type of defects are forming. The problem that we had is that collecting the data for training our model, and they were doing like 2 or 3 times per week casting, which was not enough for us to find out and then collecting those images for training our model. So we were looking for a simulation and small scale conveyor, so to be able to use the manufactured sheet and then put it under a line scan camera and collect those data for the training purposes. That's why we, through a mutual friend, we have been introduced to Fareedun and see if he can help us to make that conveyor belt like a smaller scale. So we need some specific features for that. The speed should be high enough, or it could be vary from the low to high. And then also we were easily able to attach the samples that we are collecting from the real line into that. So, and repeatedly we can record those images for our machine learning process. And we had several meetings, and then deliver what we are expecting from that machine, and that's how we start this collaboration has been started back in 22.
Thank you, Mehdi. So yeah, so as you can see, just showing a quick image of what we had designed and what we had made for AI Innovate at that time. So this high-speed conveyor system was a special type because it has to be able to run up to 18 kilometers per hour in a small lengths, just about 200 centimeters or 2 meters lengths. And as you can see, it's quite a heavy and strong conveyor for the size that is not usually used in manufacturing facilities. And therefore, we had to make a special type machine for that purpose. Addition of that, there are all sorts of adjustments, fixtures, and also for camera, lights, and also processing units that comes side to be able to use this conveyor to training the machine learning algorithms for at that time the aluminum production line, but it was designed with the mindset that it can be used for any type of continuous production line to be trained, help the machine learning algorithms to be trained, and help the engineers to use it on site. So this was how we started to working together at the beginning. Then around the same time, at CAMI, we were working with another local manufacturer, another partner called Peterborough Matboard. And this company is specialized in manufacturing mat boards, as it says. So these mat boards are technically the backing paper that you find in frames and pictures that are used in the framing industry. A lot of different type of applications in museum or handcrafts and other type of applications that these products are being used. And Peterborough Matboard were working with us at that time to design and develop a kind of a moisture control system that is able to dry their products on the production line according to having a live feedback from the content moisture of the paper, and also selectively heating and also drying the papers on the line. So we were working together with this projects with them, and they approached us around at the same time and asked us to help them to find an answer for needs that they had on the production line. So essentially, at the end of their production line, they always had an operator that's standing there and watching these paper passing by at a high speed on the conveyor. And just by looking at them, the operator has to decide whether this is an acceptable product or not. So essentially, any small defects, even a small dot on the product, resulting into rejection because the final customers won't accepting them. So the operators are standing there and all time looking at a white paper that passed through, pass in front of their eyes, or sometimes different colors. White is their most one of their common products. And so that means there are 2 production lines, so you need to have 4 people, because this is not a task that you can have one person to do over a long period of time. So they're rotating their operators at the end of the line. So you need 4 people standing there looking at these papers, a tedious job that is also not necessarily consistent, because operator to operator, their eyes and their sensitivity changes. So we work, Peterborough Matboard asked us if we can find a solution for this problem. So we done a couple of different studies, find some of the off-the-shelf products from manufacturers that are famous in this area, like Keyence and Cognex, brought them in, try to see if their solutions are going to be some good for this type of applications. But in every time that some of the off-the-shelf products presented, it came out that this, although there might be a really good camera systems, but there was always implementation process and the reporting needs there. So how you're going to integrate with the specific type of the product you have, and also how you generate the reports out that shows the quality of your process and all the information needed for product and process improvements. These are the things that usually you will not be able to get from the off-the-shelf products, and you need to have some customized solution. Specifically for the Peterborough Matboard, the length of the product size, the color of the product, and the speed of the line will introduce a lot of limitations to using off-the-shelf solutions for this problem. So then, while we were working with two different partners on two different type of projects, it came to our mind that we can connecting the dots and connecting our partners together to work together and technically solving problem for the Peterborough Matboard, and also helping AI Innovate to improve their products and bring it into the new manufacturing markets. So we kind of establish a three-way collaborative projects together where AI Innovate, Peterborough Matboard, and CAMIT work together. AI Innovate is going to provide the AI and machine learning algorithms and adoptions of development of a customized system that is able to provide reporting required and also inspection required for the Peterborough Matboard productions. Peterborough Matboard definitely is where this whole system is being developed and is now currently under use. And at CAMIT, we were able to help both partners by developing hardware, mechanical and electronics hardware required for this machine vision AI-based quality control system. So we put our efforts together and develop a product that later called AI2I, one of the major products of the AI Innovate. So this product technically came throughout these three-way collaborations that CAMIT enabled it, and we were mainly involved in design and development of the hardware on both mechanical side and the Edge AI computational power. And as I said, AI Innovate work more on the software and machine learning and AI engineering part of the work. So this is now the production. The system is being installed on the Peterborough Matboard production side. And as you may remember previously, at the same point, we had an operator standing all day looking on the papers, passing one by one. But now this machine vision system is replaced, and the operator can spend their time doing more of a productive work and also operate the machine on a better term and form, rather than standing and doing quality control all day at the end of the production line. So passing it to Mehdi to more talk about the AI2I features and benefits.
Sure. Thank you, Faridun. Yeah, as Faridun mentioned, we were mainly involved in the software development, from back-end user interface and cloud, and then computational part of it. And as you can see, this is the interface of the products. It has a different units, and it can be customized based on the client's unit. Here in Peterborough, we mainly need to determine what color we are facing with, and then how many board has been manufactured, what's the size of those, and if there is any inconsistency, it can be reported, and then it can be recorded for the later on root cause analysis, as I mentioned at the beginning. By using this, so we have the real-time defect detection, 100% of inspection. So we were inspecting every board without any interruption. And so far, the the operational efficiency is went up to around 30%. We have the system installed about 18 months so far, and especially like the reduction of the downtime. So as Feridun mentioned, the operators and are more free right now. They can do other stuff at the same times, and then with the same time that they have, they can focus on the other jobs rather than standing there and do the quality control manually. And what we also learned here, because this line is an old line, so it was working in the past 30 years. So the integration of our system into the current system was a big challenge at the beginning, but we were able to integrate that. And then with the current version of AI2I, we can easily can be integrated to any PLCs, even the old version of that. So, and communicate with the current established and the hardware that is being installed there. And that's the general features of AI2I so far. And okay, back to you, Feridun.
Okay, thank you. So that's successful adoption of the technology and helping the manufacturer throughout this three-way collaboration enabled us to looking into more further work with this manufacturer. So now in the next steps, technically, AI Innovate were enabled to work with the Peterborough Math Board to secure more fundings, this time through Engine, to help them to adopt the same technology in their second production line. So this company is around more than 100 years, Peterborough Math Board, and they have a dryer machine on their second line, which is more than 130 years old. So you see an old picture of that. This machine is now currently running at their facility and still in use, but it doesn't have the features required to be for the nowadays quality that our customers need from Peterborough Math Board. So now AI Innovate and CAMIT will work together again, adding the AI2I and machine vision quality control system to this line and enable it to be more productive. And also we are going to enhance our moisture control systems, the one that initially we worked with them, to be added to this machine as well. So both of the previous implemented technologies at the first line now will be implemented on the second line and help the company to expand their use of AI and technology there. Also, maybe you can chime here how AI Innovate is able to use in the next steps the development happened.
Sure. So for the next step, and we are trying to improve the edge AI hardware, and you can see the new design here is the integration is much better. We have now a compacted system that it can be easily integrated to the other line and have also much more. It looks very nice in compare with the first version that we designed with the help of Feridun. So, and also we are developing AI2I for the 3D objects, and we are working with the company to have their pipe inspection with the new design that you can see here. So this product now is working in a textile manufacturing setups, and the aluminum and metals that we are talking, it's happening right now, and also with the sorting company that they are trying to implement an AI-enabled cameras to be synchronized with each other. We are working with them to implement the AI2I to their system instead of having individual cameras. We are trying to be able to communicate with together to have a better training phase, and also implementation in the real-time setup and detecting the samples and the defects as well. Recently, with the help of Fredun, also we are going after even agriculture system in the for the smart irrigation system for the greenhouses as well. We will use a different type of cameras, like hyperspectral cameras, to have a correlation between the output of the hyperspectral camera with the water stress that the plant might have, and have a smarter irrigation system than what they have currently, and then save some water and also the nutrition that they have, and also added the early monitoring of the health of the plants as well. And so generally, the lesson that we learned from the field and working with with Fredun and his team is that we need to start with the specific use cases. Here, we were fortunate that the clients came to us with the specific needs, and that was the quality control of their boards. So we were trying to overcome that. So it's depend on the clients. Sometimes they need on-premises computational units, which was the case here, but some of them are okay with the cloud-based computational system. So we need to be ready for what the clients are looking for, based on the privacy that they are looking for, or the establishment and they have in their current manufacturing line. One of the very encouraging aspects of this project is that the frontline staff and operators were very supportive of this. We were have a challenging that they might have this feeling that we are replacing them and their job with the machine, but it was not the case for this project. So we have a very nice collaboration, and give them this feeling that this will help you for your job, and then you will be free time to go after your other tasks. And we receive very nice feedback. Those are the people that they are dealing with the problems every day. So for all the aspects, from the training and collecting the data up to implementing the new systems, and also giving us the feedback, how does it work, and then how we can improve the efficiency and all of the solution. They were a big help in this project. And collaboration with Fredun was great. It is if the Fredun and his team were not here, probably we cannot even start this project and then implemented this. And this is a good example of collaboration between an industry and academic research. Through the funding that we are receiving through the government, it was much easier for a small company and a startup like us to support the R&D activities, which was a great help, and also implemented in the real setup. And a challenging that we face in terms of like technically, the data quality is very important for a machine learning setup, and it's different when you're dealing with the problem at the floor and in industrial setup. We had, and that's how this collaboration actually has been started, with that conveyor belt, the small one that we were designing with Fredun, which was a great help during this project as well. And again, working with the frontline people, it will make it easier for us to have a good quality data for the training the model at the beginning. And adoption and change the management mindset is a big issue, and don't interrupt their day-to-day operation, and then working after hours sometimes to be able to implement and install the machine and working and updating your system. It was a bit of challenge, but that's understandable. And then we understand we need to be a bit of have a bit of flexibility there to work with the management and then the operational people on the floor. And again, integration with the existing system. Some of this system is pretty old with the old technology, so connecting and integrating them with the design and the new technology such as this was not easy, but learning lessons from this implementation help us to go after other opportunities and try to implement the technology to the other similar setups. Thank you.
Thank you, Mehdi. So this is concluding our talk. So now we can open the floor for discussion and question.
Please feel free to put any of your questions into the chat. We can read them out. Okay, so one that came in was, what scalability challenges do you foresee in bringing this type of customized AI hardware to more Canadian manufacturers?
So I can start, and Mehdi, if you'd like to chime
Sure.
in. So definitely, as I mentioned, there are a lot of potential for Canadian manufacturers to implement a similar AI and in specifically similar technology on quality control. And just in this one example, development of a system for aluminum production line converted into paper production line, and now, as Mehdi mentioned, for fabric. So it's not necessary just repeating the same process every time, but they are repeating the same steps. So the solution needs to be customized, needs to be tailored to the new production line manufacturing. But it is it's getting streamlined and make it much easier for technology providers to do that. And that means it's going to be really scalable and with a very low considerable amount of cost. So the cost of deploying a system like this, it's very, very affordable comparing to benefits that is bringing in and the cost saving that is resulting in a way that this similar system can easily have a return on investment of less than a year for a manufacturer. So it's making it much more pleasant and scalable for on the larger scales. Mehdi.
Yes, just one point add to what Fredo said is that what we learned in the this implementation of this type of products is that sometimes the client want to see it much earlier. So at the working with the mat board, it took us about 2 months to collect the data for the training. What with the advancement recently currently happening in the AI and the AI models, we came up with this idea that to be able to deliver the very first version of the products on their line, we are using different type of algorithms such as like a zero shot or a few shot learning, instead of focusing on the training a model with the different data and then annotate them. Got the very first version on the line, and then it's probably the accuracy is lower, like for the textile that we are doing recently is like that. But with the implementing that, we are doing the collecting data phase as well, so and then improving the data. But the clients from the 2 or 3 weeks of the contract that they are signing, they will see the implementation of their products in their line, and that's the good sign for them that this is not taking so much time to be implemented in their lab.
Awesome. Okay, another one is, what advice would you give to students or early career professionals wanting to enter AI-powered manufacturing fields?
Maybe do you want to start?
Yes, um, s- like looking at the probably a real case scenario such as here, and then put themselves in the shoes of the owners or the manufacturer. How this can help them, like how it can like save time and resources and money for them. Sometimes after early days of my graduation, also it was happening that we were more excited about the project rather than like helping uh, the clients or customer for saving and the resources and how this could help them in general. Probably that's how you can think about the project, that this at the end of the day it should help your client to overcome a challenge. Like yeah, the technology and how you are using and then how you are developing, that's very exciting, but at the same time think about the overall picture and then how this could help the client as well.
Yeah, just if I want to add in, although it may sounds really complex and sometimes it might be students specifically to, thinking getting into this field, it might be really hard or even scary, but it's not really that case, even with the knowledge they achieve in their trainings at the college programs or university programs. Just getting involved in the real world problems will give them the courage and also the skills they need just by learning it on the field. So that being said, just trust yourself, your skills, and I'm sure that's we had students involved that are in these projects, and they many things they learn on the field as they work on them, and it can be happening for any other of them.
Great, thank you. If there's no other questions in the chat, we can wrap it up.
Thank you.
So thank you so much, Feridun and Mehdi. Maybe if you'd be able to send your slides to us, we can distribute to attendees if there's interest in that. We really appreciate you taking the time to lead us through this session. It was great. Thank you to all of our attendees for coming. Our next session is January 29th. It's going to be led by Centennial College and focus on smart mobility. So we're going to post that link into the chat for you to be able to learn more information and to register. There will be more sessions for the speaker series in 2026. You'll be able to find them on our website, which will be linked in here again. So take a look there, and we hope that we see you in future sessions moving forward. Thank you, everybody, and have
Thank
a
you.
wonderful rest of your Thursday.
Thank you, everyone.
Thank you.
Thank you, everyone.